Okay, section 2.5 on the zeros of a polynomial. So first thing we're going to look at is the rational zero test, which just gives us an indication of possible zeros for a function. So you're always going to take the factors of the constant term over the factors of the leading term. So for example, if I have 2x to the third minus 3x plus 5, I'm going to take the factors of the constant term, which are the factors of 5, and divide by the factors of 2, which is the leading term. So the factors of 5 are 1 and 5, and the factors of 2 are 1 and 2. So I'm going to list out all of the possibilities. So it's always positive and negative. I'm going to do 1 divided by 1, 5 divided by 1, 1 divided by 2, and 5 divided by 2. So you just list all of those out. If you can simplify them, go ahead and simplify. So this is going to be positive and negative, 1, 1/2, 5/2, and 5. So these are the possible solutions for a polynomial. Instead of just all the numbers in the world, I've narrowed it down to these possibilities. Okay, next is Descartes' rule of signs. And this is to determine if our solutions are positive or negative. How many of them are positive solutions and how many of them are negative solutions. To find the number of positive real zeros, you're going to count the number of sign changes of the function, and it's always going to be less than that number by an even integer. So if you count 5 sign changes, it can be 5, 3, or 1. If you count 4 sign changes, it can be 4, 2, or 0. So you always subtract 2 until you can't subtract anymore. For the negative zeros, you have to change the function to f of negative x, then count the number of sign changes, and it's the same rule. It's that number of sign changes or less than that by an even integer. So let's look at an example using Descartes' rule of signs. So I have the function f of x equals 2x squared minus 3x plus 8. So first thing I'm going to do is count the number of sign changes for this function. So it goes from positive to negative to positive. So that is actually one sign change from positive to negative and another sign change from negative to positive. So that's 2 sign changes. So 2 sign changes equals 2 or 0 positive solutions or zeros. So there will either be 2 positive solutions or no positive solutions. There's never going to be an in-between. Now we're going to take the function and we're going to substitute a negative x everywhere there's an x. So 2 times negative x squared minus 3 times negative x plus 8. So you go through and simplify this. A negative x squared turns into a positive times the positive 2 that's already there will be a plus 2x squared. Negative 3 times negative x is going to change to a plus 3x, and then plus 8 is going to stay the same. So I count the sign changes. This is positive all of the way, so there are no sign changes here. So 0 sign changes means that there's going to be 0 negative solutions. So all of the solutions for this equation will be positive answers. Okay, so these are just tips and tricks to help us figure out possibilities for the solutions of a polynomial. Okay, the rule for complex zeros is that a plus bi is a solution, then its conjugate, a minus bi, is also a solution. So this is just a rule of thumb. If an imaginary number becomes a solution, its conjugate is also a solution. So it's kind of a 2-for-1. Okay, so let's look at an example here. I'm going to do all of the things that we've talked about. I'm not going to solve this problem. I'm just going to find all of the possibilities to help me if I was going to solve it. So we're going to start by the number of real zeros. So you count and look at the highest exponent for the polynomial function. That will tell you the possible real number of zeros. Okay, so that's 4, since the highest exponent is 4. So that means there's going to be 4 solutions. Okay, next I'm going to do the positive solutions. So I'm going to count the number of sign changes for this function. So from positive to negative is 1. From negative to positive is another one. Positive to positive, positive to negative is another one. So I have 3 sign changes here. So that's going to be 3 or 1 positive solutions. Okay, and then for negative solutions, I have to change my function and change it to f of negative x. So everywhere there's an x, I'm going to substitute a negative x in parentheses and simplify. So 2 times negative x to the 4th is going to change to 2 times x to the 4th. Any negative to an even exponent is going to become positive. Then when I have negative x to the 3rd, that's negative, times the negative that's already there is plus 17x to the 3rd. Okay, then a negative x squared is positive times the positive that's already there, so plus 35x squared. 9 times negative x is going to be negative 9x, and then minus 45. Okay, so I've simplified my equation. Now I need to count the number of sign changes here. So positive to positive, positive to positive, positive to negative is 1 sign change, and then negative to negative. So only 1 negative solution here. So if I was going to solve it, I would only try 1 negative number. I wouldn't, if I got 1 negative answer, I'm not going to keep trying negative answers because there's only 1. Okay, now we're going to list the possible solutions. So this is where we take the factors of the constant over the factors of the leading term. So factors of 45 over the factors of 2. The factors of 45 are going to be 1 times 45, 3 times 15, and 5 times 9. All of those are things that multiply to get 45. And on the bottom, the things that multiply to get 2 are just 1 and 2. So I'm going to list all of these out. Everything on the top divided by 1, everything on the top divided by 2. Okay, so these are all of our possible solutions. That doesn't mean these are the solutions. These are the numbers that I could try using synthetic division and see which ones work. Okay, so for this problem, that's all we wanted to find out. How many solutions, how many positives and negatives, and then what are the possible ones. Okay, so on number 2, they want us to find all of the solutions, and they've actually given one that they say works. So what we do is we do all the things that we did on example 1, then we can start at this point and actually find the solutions that work. So we're going to set up using synthetic division. We're going to take the coefficients of the polynomial, and those go inside. So 1, negative 6, 11, and negative 6. And then the solution that they say works goes on the outside. So we're going to do synthetic division. So even though I know this works, we still want to do synthetic division to get a simpler equation. So when we're doing synthetic division for a solution, we want a remainder of 0 at the end. So you bring down your first number. 1 times 1 is 1. Negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. 11 minus 5 is 6. 6 times 1 is 6. Negative 6 plus 6 is 0, which is what I want. I want a remainder of 0. So what we could do is we could continue using synthetic division if I knew some other possibilities and could continue solving it this way. Also, for this problem, this is the same as x squared minus 5x plus 6. And I could try to factor and see what works for this equation. So if I try to factor this, I know that x times x equals x squared. And then I would try to find a term that multiplies to get 6 and adds or subtracts to get negative 5. Okay, so that's going to have to be negative 3 and negative 2. So then I set those two factors equal to 0, and I solve. So x equals 3 and x equals 2, and the 1 that they already gave me. So 3, 2, and 1 are all of the zeros for this polynomial. If I had my list of possible solutions, I could have used synthetic division to continue solving. But once you get it to a quadratic equation, you can either factor or use the quadratic formula if that's easier. Okay, so let's continue on example 3. We're going to find all the zeros, and this time we're given that one of the zeros is an imaginary number, 5i. So earlier I said that if an imaginary number is a solution, then its conjugate is also a solution, which is negative 5i. Okay, so we're going to use synthetic division, and we're going to start with the first imaginary solution, 5i. Once we simplify that, then we'll try the second imaginary solution, negative 5i, and see where we can go from there. Okay, so when you're doing imaginary numbers in synthetic division, go slowly, double check your numbers, and think about it. So bring down the first term. 2 times 5i is 10i. When I add 3 plus 10i, I can't add those together. They're not the same term. So I just write 3 plus 10i. Now I'm going to multiply. 5i times 3 is going to be 15i. And 5i times 10i is 50i squared. And we know that 50i squared would change to negative 50. So this is negative 50 plus 15i. And you'll notice when I do 50 minus 50 plus 15i, the 50s cancel and I'm left with 15i. So now when I multiply 15i times 5i, that's going to be 75i squared, which is negative 75. And I get a zero remainder, which is correct because it said that it was a solution. So now I'm going to continue on from this one, and I'm going to use negative 5i and find if I can, or see if I can find the other solution to this polynomial function. So I bring the 2 straight down. 2 times negative 5i is negative 10i, plus the 3 plus 10i that's already there will just give me 3. 3 times negative 5i will give me negative 15i, which is going to cancel and give me a zero remainder, which is what I wanted. Okay, so the green equation that I started with was a cubic function. The blue equation in the middle would be a squared function, and now the yellow function at the very end would be x to the first power. So really this is 2x plus 3 equals 0. Well, I can solve this. I'm going to subtract 3 and divide by 2, and I would get x equals negative 3 over 2. So the solutions to this polynomial are negative 3 over 2, 5i, and negative 5i. Okay, now for the last example, we're going to go through all the motions that you need to go through for section 2.5. Every little thing that we need to find when we are solving a polynomial function. Okay, so we have the function x to the 5th minus x to the 4th minus 3x cubed plus 5x squared minus 2x. So we're going to start by stating the possible number of zeros, how many solutions there's going to be. So I know that there are going to be 5 solutions to this polynomial because 5 is the highest exponent. Now I want to know how many positive zeros there are going to be. So I need to count the number of times that the sign changes in the function. So from positive to negative is 1. From later on we have a negative to a positive, that's another 1. And then from positive to negative at the end is another 1. So that's 3 sign changes altogether. So that means there will be 3 or 1 positive solutions. And remember, you subtract 2 because they're always in even increments. They go up or down by 2. Okay, so now we're going to do negative zeros. So in place of x, I plug in a negative x, and I need to simplify. The rule is a negative x raised to an odd power will change the sign in front of the parenthesis. If it's a negative x raised to an even power, it's going to keep the sign in front of the parenthesis. So it's going to be negative x to the 5th, that changed the sign in front. This keeps the sign. Odd is going to change. even is going to keep, and then odd is going to change. So then we count the sign changes for this function, and there's only one time that it changes, so that means there is one negative solution. Now I need to list out the possible solutions. For the possible solutions, we do the factors of the constant over the factors of the leading coefficient. Well, the constant term here is 0. So 0 over 1 is just going to be 0. So we're going to start with 0, and then we'll come back and try the possible factors again with our new function. Okay, so we're going to use synthetic division. The coefficients of our polynomial go inside, and notice I put a 0 at the end because I'm missing that constant term, and then a 0 on the outside. So we bring down our 1. 1 times 0 is 0. Plus negative 1 is negative 1. Negative 1 times 0 is 0. Plus negative 3 is negative 3. Times 0 is 0. Plus 5 is 5. Times 0 is 0. Plus negative 2 is negative 2. Times 0 is 0. Plus 0 is 0. So it kind of looks like we didn't do anything here because it's the same numbers that we started with. But remember, the green function that I started with was to the 5th power. This blue function is now to the 4th power. I've simplified the function by knowing that 0 was a factor or a solution. Okay, so now I want to know the possible factors again. You're not going to have to do this every time. But the factors now are going to be plus or minus 2 over 1. So factors of 2 over factors of 1. Well, that's just going to be 1 and 2 over 1 is just positive or negative 1 and 2. Okay, so we're going to continue on with synthetic division using these possibilities. We have one solution, so now we just need 4 more. Okay, so I set up for synthetic division, same numbers on the inside. I'm going to try a positive 1 on the outside. So bring down your 1. 1 times 1 is 1, plus the negative 1 that's there is 0. 0 times 1 is 0, plus the negative 3 is negative 3. Times 1 is negative 3, plus 5 is 2. Times 1 is 2. Remainder of 0. So that's good. That means this is a solution. So now we're going to continue on, and I'm going to find the other possible solutions or see what other possible ones work. So I'm going to start with negative 1. Bring down your 1. 1 times negative 1 is negative 1. Plus 0 is negative 1. Times negative 1 is positive 1. Plus negative 3 is negative 2. Times negative 1 should be positive 2, plus 2 is 4. So I don't have to use that blue 0 up there. It's gone. I don't need it anymore. But I didn't get a 0 remainder, so that means that negative 1 is not a solution here. So I'm going to erase this, and I'm going to try the next number on the list. I'm going to try positive 2. So I bring down my 1 times 2 is 2. Plus 0 is 2. 2 times 2 is 4. Plus the negative 3 is 1. 1 times 2 is 2. I'm not going to get a 0 remainder for this one, so positive 2 is not a solution. So I erase, and I try the next number on the list, negative 2. Bring down the 1. 1 times negative 2 is negative 2. Plus 0 is negative 2. Times negative 2 is positive 4, plus negative 3 is 1. 1 times negative 2 is negative 2, plus 2 is 0. So that means this is a solution. So remember, we started with x to the 5th, then we had x to the 4th, x to the 3rd. Now this is x squared. It's down to something I could factor. So on the next slide, I'm going to use this, and I'm going to factor the equation x squared minus 2x plus 1. So I set up my parentheses. Well, I know that x times x equals x squared. And then I need to know what two numbers will multiply to get 1 and add to get negative 2. So that's going to be negative 1 and negative 1. Negative 1 times negative 1 is positive 1, but negative 1 plus negative 1 is negative 2 in the middle. So I set these equal to 0, and I find out that x equals 1. 2 times, so that has a multiplicity of 2. So when I list out my zeros, I have 0, 1, negative 2, 1, and 1. So here's my 5 total solutions. If I wanted to, I could rewrite it and say I have 0, 1 with a multiplicity of 3 because it actually showed up 3 times, and then negative 2. Whichever way is fine with me.